Moore's Law. So, in this video, we're going to talk about what happens when you add an ionic compound to a solvent, right? Unlike last video. But before I talk about that, and y'all probably know this better than me, so I might be wrong here, but I'm pretty sure. I want to say what vapor pressure is because I didn't discuss that last video. So real quick, vapor pressure is basically the pressure exerted by a vapor with its condensed phases at a given temperature in a closed system. So this is a condensed phase. Liquid and solid are both condensed phases. This is non-condensed, it's gas. So the pressure exerted by this gas over this liquid in this closed container is this liquid's vapor pressure. So when you stick a liquid or stick a bottle of water out somewhere, it's going to start to evaporate. Even if you close it in a closed system, it will evaporate some, and some gas molecules will form above the liquid, and the pressure that these gas particles exert down is the vapor pressure of the liquid, and it eventually evens out and becomes an equilibrium. The amount of liquid that's evaporating is equal to the amount of gas that returns back to the liquid phase, because the gas does return to the liquid phase, and eventually it will become an equilibrium. But that's the vapor pressure. So here we go, y'all. Not going to take that long on this one. Predict the vapor pressure of a solution from 35 grams of solid sodium sulfate. Now this is different than last problem. Last problem we used sucrose in the last video. Sucrose is not ionic. This is ionic, so this is going to be different. With 175 grams of water at 25 degrees Celsius, the pressure of the solvent, which is water, is 25 degrees Celsius is 23.76 torr. Solvent is the thing that's, the solute is dissolved in the solvent. So this is dissolved in water, so water is the solvent. All right, so how do we approach this? Well, okay, here's our main equation. Again, vapor pressure of solution equals the mole fraction of the solvent, which is water, times the vapor pressure of the solvent, which is water, which is given to you. Pressure of the solvent is given. So first thing we need to do is find out the mole fraction of the solvent. So we need to find out how many moles of solvent and how many moles of solute. So let's do this. Alright, so for water, last problem only told you density. This problem is giving you the grams, so this is easier. You have 175 grams of water. That's the molar mass. Basically, you have on the periodic table, H is 1, O is 16, basically, so 1 plus 1, because you have 2, plus 16, 18 about. So you have 9.71 moles of water, and then for the sodium sulfate, it tells you 35 grams times, and you can he'll probably give us this number, right? The molar mass. So times moles over grams. Grams cancel out. You're left with moles. 0.246 moles of sodium sulfate. Now here's where it is different and kind of tricky. This is ionic. This is made of ions. Na is a positive ion. It's on the left side of the periodic table. SO4 is a polyatomic ion. There's a list of polyatomic ions that are pretty tough to remember, but SO4 is a compound in itself. So this has 2 sodium ions, because you have 2. How many does sulfate have? It's only 1, because sulfate is SO4. This is not 4 sulfates. If you had a 4 out here again, it might be. But this is only 1 SO4 and 2 NAs. You need to memorize these polyatomic ions, because that can be kind of tricky. But let me write something. Let me write that. Here we go. All right, if this actually said like a 2 or a 2 out here, that didn't come out like a 2. Then you would have 2 of these. So this is just one of these, right? because that's one whole molecule. Okay, one whole compound. All right, let's speed this thing. Let's keep going. All right, so this is what we found, 0.246, but you have 3 of these, 1 and 2. So you multiply it by 3 because you have each one is taking up that many moles. So you have 3 of them. So now you have 0.738 moles. That's the total moles of the solute. So this is the moles of, you know, this is moles here, but you have 3 ions. So you have to multiply it by 3 and you get 0.738. So now we have the moles of the solute and we have the moles of the water, and we can now solve our mole fraction. So we have the moles of the water, which we found to be 9.71. We have it on the bottom also because it's solvent over solute plus solvent. So solvent moles, solute moles, 0.738 plus solvent moles. So you end up with mole fraction of water equals 0.929. And then, we're almost there. There's our equation. Here it is. Pressure of solution. Vapor pressure equals this. Moles of solvent, mole fraction of solvent times vapor pressure of solvent. So we had our moles of solvent water, and we have given in the question vapor pressure 23.76 is vapor pressure of water, the solvent. So we just multiply those two and we get 22.14 equals the vapor pressure of the solution. So we started off with 23.76 was the vapor pressure of the solvent of water, and it went down, it lowered to 22.1 when we added this compound, ionic compound, to it. So that is it for this. Check out the next video, y'all. Check out the one before it. Yeah, that's all. Cool.